Let's look at type 1 diabetes, insulin, and glucagon and what role they play. So, type 1 diabetes is beta cell in the pancreas destruction. Okay, the beta cells are what make and release insulin. And the role of insulin is to lower blood sugar levels. All right, so if we look at this diagram, how insulin works. So the pancreas will release the insulin because of high blood sugar levels due to eating. Okay, specifically carbs or sugar. All right, so blood sugar levels, they spike, and the goal is to gradually bring down the blood sugar levels. Okay, so the levels are high. We'll call it 130. And then when insulin is released, it's going to bind to glucose. And when insulin binds to the insulin receptor on the cell, it allows for this closed channel to open. Okay, so once insulin binds, the glucose channel is now open for glucose to enter into the cell. Okay, when we eat, that is considered the fed state. All right, and the typical foods that we eat are carbohydrates, fats, and protein. And as an American culture, we do consume a lot of carbs, which means a lot of sugar. Okay, so under normal circumstances, the pancreas, via the beta cells, release insulin. Okay, insulin has a lot of functions. Okay, on one hand, it transports glucose into the cells. It stores glucose into the liver muscles. And then it also converts glucose into fat. And then that fat is stored in adipose tissue. Okay, or the fat cells. So yes, it is possible to eat carbs and gain fat weight. Okay, insulin inhibits glucagon, and we'll talk about glucagon in a minute. And insulin lowers blood sugar levels. Okay, insulin is also anabolic. And the way it's anabolic is it increases the transport of amino acids, okay, which is the end product of the breakdown of protein. All right, so those amino acids will go into tissue where protein synthesis is stimulated. All right, we'll come back to that, this slide in a minute. Okay, glucagon. Okay, glucagon is activated in the fasting state. All right, by definition, fasting is about 8 to 12 hours with no food. Okay, so for example, if you have dinner at 7 p.m. and then eventually go to bed and you wake up in the morning, you're in the fasting state, okay, because you didn't eat all night. And then what people end up doing is they do a break fast. All right, so you're breaking your fast by having breakfast. So after that 8 to 12 hours or longer of no food, and then you consume food, now you have broken the fast. Okay, so glucagon is activated in the fasting state or not eating carbs. Okay, so that one actually gets into the keto diet. Not really going to spend time on the keto diet on this particular lecture, but the super quick version is a keto diet is very low carbs, lots of fat and protein, and then what happens is you stimulate the fat cells to release ketones, and the ketones are now a substitute for the glucose. Okay, now we do need glucose. All right, so this is a little bit of a weird statement because on one hand, our society gets themselves in a lot of trouble health-wise because of the overconsumption of sugar, the overconsumption of carbs, the overconsumption of glucose. But on the other hand, we do need glucose. Okay, the brain needs it, the cells need it. And if you're not going to eat glucose, if you're not going to consume it, then your body has ways of making up for that. As far as being healthy, the key is to keep your sugar intake very low. Okay, that'll be a lecture for another time. But as far as health, that's the quick version. Okay, back to glucagon. In the fasting state, you activate glucagon. And what is happening is your blood sugar levels are low. Okay, blood sugar levels are very low. Okay, so glucagon is activated. All right, glucagon goes to the liver to release stored glycogen. All right, so this is step one. Okay, this is we're going to do this in a two-step process. So this happens within several hours. Okay, so this process is called glycogenolysis. Okay, glyco is sugar. Geno is the beginning of. It makes the word genesis, which is the beginning of or the creation of, and then lysis is breakdown. All right, so the liver has stored glycogen, and if your blood sugar is getting too low, within a couple hours, your body will begin this process. Okay, glycogenolysis. And what that does is it increases blood sugar levels. Now, if you continue to not eat in step two, so no food or fasting, 8 to 12 hours or longer. Okay, everybody's different. It could take 15 hours for this to kick in, but roughly about 8 to 12 hours or longer. Okay, we'll call this prolonged fasting. Then you get gluconeogenesis. Okay, so you're going to activate, or glucagon is going to activate gluconeogenesis. Okay, now I spread that word out on purpose, the prefix, suffix, and root word. Okay, glucose is sugar, neo is new, and genesis is the beginning of or the creation of. So you are making a new sugar from a non-carbohydrate product. Okay, so this is the making of glucose from a non-sugar product. Okay, so an example is amino acids and lactate. Okay, the liver can convert these into glucose. And then when this happens, you raise blood sugar levels. Okay, going back to diabetes. So type 1 diabetes. When you eat carbs, blood sugar levels increase. Okay, you need insulin to lower blood sugar levels. But a type 1 diabetic cannot make or release insulin, so they have to do an insulin shot. Okay, so diabetes unmanaged will eventually cause thickening to the blood vessels. Okay, so this takes years and years to happen, but that chronic high blood sugar, because of things like advanced glycation, end product, oxidative damage, decrease in nitric oxide, the blood vessels can't relax, the blood vessels leak, the blood vessels thicken. It starts to hurt microcirculation, and so that's why blindness can set in. coronary artery disease, renal artery disease, peripheral artery disease, even damage to the brain can occur because of the damage to the microcirculation.